Alright, so in this next video, what we're going to be doing is we're dealing with properties of exponents with rational exponents. This is going to be a little bit more difficult than our previous one. So if you would please put this down in your journal right here. And I need you to write down this problem carefully in your journal. We're going to do 4 problems together. Now these 4 problems aren't going to take long if you just follow along, but you need to know how to do them. Okay? So if you can't see this, this says 3, and then there's a radical, and then in the index there's a 4, and this is a z, and this is times 3, and we have z to the power of 3/4. Okay? And what we're trying to do is we're trying to get it into this form. All right, where it's k times z to the power of n. K is just a constant, just an integer. So the very first thing I need you to understand what you need to do, I need you guys to take this part right here. Take that part. And we need to change it to what's called a rational exponent. So this is z to the power of 1. So I could write 3 times z to the power of 1/4 times 3z to the power of 3/4. Now I don't have to put a dot right there. I can just put a 3 right in front of it. There we go. Does everybody see now that we have these are exactly the same? All right? So right now, what I want you to do is I simply want us to think about what we have. We have a 3. We have a z to the power of 1/4, and we have another 3 and a z to the power of 3/4. Right now, can we do 3 times 3? What is 3 times 3? 9. So I'm going to put 9. But how do I rectify the z to the power of 1/4 and z to the power of 3/4? You add them together. All right? So what can we do? We can take z. See how they are the same? What are we allowed to do with the exponents? Take 1/4 and add it to what? 3/4. And that becomes 4/4, which just becomes a 1. All right? So right now, what I want us to do right now is I want us to understand our final answer is going to be what? 9 times z. But I don't have to put z to the power of 1 because it's automatically assumed that it's there. So I'm just going to put 9z. So what did we do with the coefficients? The coefficients, what did we do? We multiplied the coefficients together. And what did we do with the exponents? We added them together. So I'm just going to type in a 9z. Okay? All right, here's the next problem. Looks kind of hard. It says the square root of x to the power of 3/4 times, I'm going to put times because that's basically what it means, times x to the power of -1. The first thing I want you to do is inside of this radical, what are we allowed to do with these exponents? Does anybody know what we're allowed to do? We're allowed to add them together. So inside of this radical, could you please put x to the power of 3/4, but just add a -1? That's what I want you to do. Take 3/4 and add a -1 and tell me what you get. Very good. You get -1/4. So put x to the power of -1/4. So this is where students will like, what do I do from here? So they figure out this part that they needed to add them together, and they get here and like, what do I go? Where do I go? So listen, if this is a square root, what index, this is called the index, what index would have to be in a square root? The index would have to be the number 2. So anytime you see a square root, even though you can't see it, what number could be in there or should be in there? 2. But they're not going to say that because they automatically expect you to know that that's a 2. Now, we have a rule. If I say the square root, or actually put the nth root of b to the power of m, if I change this to a rational exponent, this is what we learned yesterday. All right? We learned this rule yesterday. That was like the first thing that we did, is if you have an index and you have a base to a power, it's always m over n. It's always this power over this power. So what power is going to go on top? What would you guys say? If we use the same pattern. Negative 1 over 4. Very good. Negative 1 over 4 is on top. What power is in the denominator? 2. You're like, well, how in the world am I supposed to be able to do that in my head? So in your head, this is what you would do. You take negative 1 over 4, and if you divide something by 2, that's like multiplying a fraction of a half, which gives you negative 1 over 8. So what is my final answer going to be? X to the power of negative 1/8. That's going to be my answer. Like, well, I can't do that in my head. That's okay. That's okay. You just go to your graphing calculator, hit alpha y equals, enter. Then you're going to have to do another alpha y equals, enter. And you put what? Negative 1 over 4 and divide it by a 2, and you hit enter. And what does it say? Negative 1/8. Or you could do this way. You could take parentheses. Negative 1 divided by 4, close parentheses, and divide it by a 2. And you still get this decimal, but you'd have to change that to a fraction. All right? So understand, what did we do here? We added those together. We got that fraction, and then we moved it to this form, rational exponent form, and we simplified it. So I'm going to type in, for our answer, x to the power of a fraction. And what's our fraction? Negative what? 1 over 8. All right? Okay, let's do another one. I'm doing 2 more, and that's it. All right? 2 more. That's all you got to deal with. 2 more problems. Now, it's hard to see, but does everybody see that we got a big old radical right here? But what's in the index? It's kind of hard to see up there. It's actually a 3, so put a 3 there. All right? Then right here, you're going to put y squared, and you're going to put y to the power of 4 over 5. So very nice and neat in your journal. I need you to carefully rewrite that expression. What I always do first is I always ask myself, can I get this into a more simplified form? Now, you guys actually did this exact problem, well, not this exact problem, a problem similar to this in the previous assignment. What are we allowed to do with the powers? This is called the quotient property. So in the quotient property, you're allowed to take the powers and subtract the powers. So could you guys do 2 minus 4/5 in the calculator? Press math, enter, enter. Now, if we did 2 minus 4/5 by hand, that would give us 1. And if we took away 4/5, that gives us what? 1 and 1/5, correct? If we take away 2 minus 4/5 is 1 and 1/5. So if we multiply and we add, we multiply those together, we get 5 plus 1 it should be 6 over 5. Okay? So in the calculator, if you did 2 minus 4 divided by 5, hit the math button, press enter twice, what do you guys get? 6 over 5. So could you guys please, I want you guys to see the progression. It's not that difficult. We got the cubic root of y to the power of 6 over 5. So this became this right here, which ultimately became that right there. All right, so once again, what rule do we have to use? Do you guys remember this rule where I have n and I have b to the power of m from yesterday? So now, here we go. We have y to something over something. Well, what has to go in the denominator of this fraction? 3. Good. And what's going to go in the numerator? 6 over 5. So if you were to do this by hand, all you'd have to do is take 6 over 5 and multiply it by 1/3, because dividing by 3 and multiplying by 1/3 are the exact same thing. Numerator times numerator, denominator times denominator. What do we get? We get 6 over 15. So my answer is y to the power of 6 over 15. And that's my final answer. So what are you going to have to do probably? You might have to do this and do what? Put it in a calculator to be able to get that 6 over 15. So here we go. So this is y to the power of, wait a second, 6 over 15 can be reduced, can it? Oh, that was a close one. That was a close one. That would have been wrong. So divided by 3, that's a 2. Divided by 3, that's a 5, because 3 goes into 6 a total of 2 times. So that's going to be y to the power of 2/5. Almost caught myself there. I was like, wait a second. 6 over 15 can be reduced. All right.